Okay, welcome to this little extra bit on the end of lesson 2 for those of you who are feeling super brave and want to be able to do those questions that come up right at the end of a GCSE exam. So, this is a very typical question. It's quite a hard question, but it's quite typical. And once you learn how to do it, it's very similar every time. And my top tip for doing questions that look like this is to keep track of what's in each bag all of the time. Because if you can do that, then actually this question is really easy. But if you don't know what's in each bag, this question is completely and utterly impossible. So what's the question say? Here's bag A with some counters in it. Here's bag B with some counters in it. And in step 1, a counter is taken at random from bag A and put into bag B. Step 2, we're going to take a counter now out of the new bag B, which has got an extra counter in, but we don't know what it is, and put another counter back into bag A. So quite a lot of things happening. And so when I'm doing these questions, what I always make sure I do is I write down what's in every bag at every stage, which takes forever, but means that I stand a chance of getting this question right. So step 1 was we took a counter from A and we put it in B. So I might have moved a red counter. So I might have picked up one of these reds and put that in B, or I might have picked up a blue counter and put that in B. Now, before I go any further, I said the one thing I would always do is keep track of what's in every bag. So at the beginning, there were 5 reds in A and 3 blues. And there were 2 reds in B and 6 blues, which means that the probability of moving a red from bag A to bag B is 5 out of the 8 counters, and the probability of moving a blue over is 3 out of 8. And before I go any further, underneath, I'm going to now write down what's in each bag, because if I do that, then I know what's in each bag, and then the probabilities for the next bit are possible. So if I moved a red from A to B, then I moved one of these reds into this bag. So now I think there are 4 reds left in A and 3 blues. And there's now an extra red in there and the same number of blues. But if I moved a blue instead of a red, then in bag A I would have 5 reds and 2 blues. And in bag B I'd have 2 reds and 7 blues. So underneath here, I've written down what's in the bag if this happened, and underneath here, what's in the bag if this was the counter that I moved, which means that now when I come on to the next bit, it's easier to write down my probabilities because I don't need to remember what's in each bag, I've just written it down. So remember, step 2 was to take a counter from bag B and put it back into bag A. So I might move a red back or I might move a blue back. And let's have a look at the probabilities. So if I am moving a red back from bag B into bag A, then the probability of it being red is 3 out of 9. And the probability of it being a blue is 6 out of 9. If, however, I'm down the bottom here, the probability of moving a red back from bag B into bag A is 2 out of 9. And the probability of moving a blue is 7 out of 9. And again, I'm going to write down what's in each bag, because if I know, I can answer the question. So quite a lot of writing down here, but at least then I'll know what's in each bag and I can answer the question. So this is what was in the bag after step 1. And if I now move a red from here to here, there will be 5 reds in here and 2 reds left in here. And the number of blues didn't change because that's still as it is. Okay, so if I moved a red from here to here, there's now 5 reds in here and 2 reds in here. If, however, I moved a blue from here to here, then the number of reds doesn't change, so 4 reds and 3 reds. But now there are 5 blues left in bag B because one of them's moved back into bag A. So I've moved one of these into here, hence I've got 5 and 4. Now let's look at the bottom half of this diagram. So on the bottom half of this diagram, this is what is in each bag at the moment. So if I move a red from B to A, I think there are now 6 reds in there and only 1 red left in there, and the blues didn't change. If I move a blue Then the reds don't change. There's 5 and 2, but there's now 3 and 6. Okay, so I've done all the hard work. Now I just need to go and read the question and work out which bits I need. Calculate the probability that bag A has more reds than blues. So luckily I've written down what's in each bag with each combination of possible moves, and I'm looking for the ones where bag A's got more reds than blues. So that's this one, not that one, this one, and this one. Okay, so more reds than blues, not more reds than blues, more reds than blues, more reds than blues. So all I need to do now is work out those calculations. So here, I've run out of space on the end here. I'll see if I can squeeze it in. I'm going to do 5/8 times 3/9, which I've got as 15/72. Squeezing it in. And notice I'm not simplifying it because I'm doing it without a calculator. I'm just going to leave it as it is. It will make the adding up at the end much easier. So in this one, I've got 3/8 times 2/9, 6/72. And in this one, I've got 3/8 times 7/9, and that's 21/72. So I wanted this one, and this one. So to answer the question, finally, I'm just going to add up my 15/72, my 6/72, and my 21/72, which gives me 42/72, which I think simplifies. Gives me 7/12. But notice how easy my adding up was without a calculator because I hadn't simplified anything along the way. If you simplify it along the way, sometimes you just make that adding up a little bit more tricky. Okay?